All right, section 3.5, trinomials of the form x squared plus bx plus c. So before we get into factoring those types of trinomials, we're going to do a little bit of review on expanding, because factoring is basically reversing the expanding process. So we're just going to review a little bit of expansion. We just saw in the last math lab that we reviewed the distributive property, and in particular distributive property when used with two binomials can be simplified using the word FOIL to represent first terms get multiplied, outside terms get multiplied, then inside terms get multiplied, then the last terms in your binomials get multiplied. But it basically is just a distributive property. So let's try a few examples just to review that property. And the first one, we have x times x is x squared, and then x gets multiplied by the 5. So you're just basically distributing the x, and then you're moving to the 2 and distributing the 2. So plus 2x, and then plus 10. So that's going to give you x squared plus 7x plus 10. In the next example, we would have to actually write that as 2x plus 3 times 2x plus 3. Now, a common mistake that people make when they say 2x plus 3 squared is they will write this, and this is not equal to it. They will say 2x squared plus 3 squared, and that's not right. You have to actually take it. You can only bring that power inside to the terms inside the brackets if they are being multiplied by each other or if they're being divided by each other. You cannot bring it in across addition or subtraction. So we would have to do this by taking 2x plus 3 and multiplying it by itself. So this is going to give us 2x times 2x is 4x squared, and 2x times 3 is 6x. And then 3 times 2x is another 6x. And then the 3 gets distributed to the last term, which is plus 9. And then you would simplify by putting the like terms together, which are 6x and 6x. And that would give you 12x plus 9. And the last term, or last product, would be 3x times 3x is 9x squared minus your 6x plus your 6x, because the 2 gets distributed, and then the 2 to the negative 2 would be minus 4. So that would give you 9x squared. Negative 6x and positive 6x are going to cancel each other out, and you're just left with 9x squared minus 4. All right, so if you're okay with that, you can use that method. You don't have to draw those arrows in, but sometimes it helps just to kind of organize your thoughts. But there are two other methods you can use if you want, and one of them requires using the rectangle model, and the other requires using algebra tiles. And if you use the rectangle model, it's just basically drawing a big rectangle and dividing it up into 4 rectangles, and each box represents a term in the binomial. So the outside dimensions of the box would be, and the width of the box, the rectangle, would be one term is x and the other one is minus 3 for one of your binomials, and the other one is x minus 2. So you would put them in each section of the box. So then you kind of do almost like what you did with the times tables back in elementary school. You would take this x and multiply it by this x would give you, the product would be x squared. This x multiplied by this negative 2 would be negative 2x. So you're basically multiplying the terms in each row by the terms in each column. So then you move to the negative 3, and the negative 3 times the x is going to give you negative 3x. And then the negative 3 times the negative 2 is going to give you a positive 6. So when you put those terms, list them off, you've got x squared, you've got minus 2x, you've got minus 3x, and you've got a plus 6, positive 6. So when you combine the two terms that are like terms, the negative 2x and negative 3x, you end up with x squared minus 5x plus 6. And this would be the same answer you would get if you were to use the distributive property and go x squared minus 2x minus 3x plus 6. You see the exact same terms are generated. So it gives you the same answer. The other method is to use kind of like the idea of multiplication tables, but using tiles to represent the expressions rather than an algebraic sentence. So it would be an algebraic expression. So this would be a long tile to represent x, and then 2 white tiles to represent -2, and then long tile to represent x, and 3 white tiles to represent -3 on the other side. So when you multiply the long positive tile by the long positive tile, you get a square positive tile, because a positive times a positive is still positive. So that's going to be a shaded positive tile. Then when you multiply a rectangular strip by, so one dimension, the length, the side length by the width would be a little short negative tile, that would end up giving you a positive times a negative, so you'd end up with a long rectangular tile. And then again, long by short would be another long rectangular tile, and then long by short would be long rectangle, and they would all be negatives because positives times negatives, positive times a negative will result in a negative. Then you move to this tile right here, and this is going to be a rectangle. The first one is multiplied by a positive rectangle, so it's going to be a negative times a positive rectangle for the dimensions. So, but that would be a negative again. And then you'd have a negative dimension this way and a negative dimension this way. So that would be a negative times a negative, which would be a positive. And then negative times a negative, which would be a positive. And then again, you're multiplying this by this here now. So that would be dimensions 2 shorts, but they're both negatives. So when you combine them, they would be positive. And then this times the long one up here would be, again, a rectangular short dimension by long dimension would result in a rectangular strip, but again, that would be negative. And then again, you'd have this multiplied by each of the 3 units up here, and they would each be squares that are positive, tiles that are positive, because a negative times a negative would result in a positive. So when you look at the answer is an x squared, and then there are 1, 2, 3, 4, 5 negative x's, and there are 6 units. So you get the same answer either way. All right, so down below you can do whatever method you want. I'm just going to use the distributive property because I don't like drawing out all that stuff, it takes too much time. But if you want to use the rectangle model or the algebra tiles, go right ahead if you like drawing of those things. I'm just going to use the distributive property. So the most that I'm going to draw are the arrows, just to show you, just to remind you. And again, you don't have to put these arrows in. I'm just putting them there to help you visualize what I'm doing. So x times x would be x squared, and then x times 3 would be 3x, and then 5 times x would be 5x, and then the 5 times the 3 would be 15. And then you put like terms together, so it'd be x squared plus 8x plus 15. This one here you would have to expand first as 3x minus 1 times 3x minus 1. And then use the distributive property. 3x times 3x is going to be 9x squared. 3x times a negative 1 is going to be minus 3x. And then you move to the negative 1 and distribute that, so it'll be minus 3x again. And then to the minus 1 times the minus 1 will be positive 1. So this would be 9x squared minus 6x plus 1. Our next example, we'd have 2x times 2x equals 2x squared. 2x times a negative 2 would be minus 4x. And then plus 1x, or you don't have to put the 1 in, you can just say plus x. And then minus 2. And that would give you 2x squared minus 3x minus 2. And the last one, you'd have 3 times 5 would be 15. 3 times a negative x would be minus 3x. And then negative 2x times 5 would be negative 10x. And then negative 2x times a negative x would be plus 2x squared. And that would give you 15 minus 13x plus 2x squared. Now, a lot of times when you have a trinomial like that, this trinomial meaning 3 terms in your expression, you would usually put the x squared term first. So in the answer key in the back of the book or whatever, if you're checking your answers, you might see it written, not written exactly by this step, but in the order of the x squared term first, then your x term, and then your constant. That's typically the way polynomial type expressions are written, in order of descending powers of the variable. Okay, so our next topic is on factoring. So now we're kind of going to look at what we just did with multiplying and kind of examine it a little bit more for polynomials of the type x squared plus bx plus c. So when we're going to work backwards now and look at when we start off with factors that give us polynomials of that type, is there some kind of connection between the numbers? And that will help us kind of reverse the process so that if we're starting with the polynomial, we can get the factors. So if we look at multiplying out x plus 5 by x plus 3, we can see that your expanded form would be x squared plus 3x plus 5x plus 15. And when you examine those middle terms here, the 3x and 5x, because they go together to form the 8x, you notice that, well, those two numbers just add up to give you 8x. Those two expressions add up to give you 8x. The coefficients, basically, 3 and 5 add up to give you the 8. And when you look at the last term, 15, and compare it to those two numbers that we just used to combine to give us 8, you notice that 3 and 5 have a product of 15. So if we go on to the next example and see does that same kind of pattern show, we see that it does, because if you multiply out x minus 4 by x plus 2, you will end up with x squared plus 2x minus 4x, which are two numbers that add to give you the middle term of negative 2x. And when you multiply 2 and negative 4, you do get that last term of negative 8. So that's basically the little rule that you can kind of follow to help you factor. When you are factoring polynomials of the type x squared plus bx plus c, so this type right here, you would be looking for two numbers that multiply to give you c and add to give you b. So they have to multiply to give you that constant term and add to give you the coefficient of x. Now that will only work, this method will only work if it's a polynomial of this type, x squared plus bx plus c, meaning there's a coefficient of 1 in front of the x squared. We call that the leading coefficient when they're written in order of descending powers. So that coefficient of x squared there is 1. So if we can find two numbers that multiply to give us the value of the constant and add to give us the value of the coefficient of the middle term, the one coefficient of x, then we can factor the trinomial. Okay, so if we look at the next example there, we've got x squared plus 11x plus 24. So we would be looking for basically two numbers that multiply to give you the constant, which is 24, and they have to add to give you the coefficient of x, which is 11. So we're looking for two numbers which have a product of 24 and a sum of 11. And if you can't think of it off the top of your head, just list off all the numbers that multiply to give you 24, or the factors of 24. And when you list them off, you can see that 3 and 8 will add to give you 11. So those are the two numbers that we need. And that means that the factors are x plus 3 and x plus 8. And you can check that if you want to see if it's correct by using your distributive property. X squared plus 8x plus the 3x, multiply this by this, and then plus the 24. So, and that will simplify to x squared plus 11x plus 24. So you know that this is the factored form. These are the factors of x squared plus 11x plus 24. Okay, so we're going to try a few examples here. So, and again, you don't have to write this step in, but I just find it helps when you're learning to write this down. This is what you're thinking. You're looking for two numbers which multiply to give you the constant term, which is 18, and add to give you the middle coefficient, which is 9. So if you think about the factors of 18, 3 and 6 will multiply to give you 18, and will add to give you 9. So in terms of factors of that expression then, we know that the first two terms have to be x, because x times x will give you the x squared, and then the two numbers will be used, plus 3 and plus 6. And you should, until you just kind of get the hang of it, you can do this on paper, or you can just do it in your head, and if you check to see if that is the correct factoring, you would see that x times x does give you x squared, x times 6 does give you 6x, 3 times x does give you 3x, and 3 times 6 does give you 18, and that will combine to give you x squared plus 9x, right, plus 18. And so these are, this here is the factoring of x squared plus 9x plus 18. So this here is our answer here. This is only a check down here below. So the next one, we're looking for two numbers which multiply to give you positive 40, but add to give you negative 14. So if you think about that, you need two numbers that multiply to give you a positive, but add to give you a negative. So if they multiply to give you a positive, that means they both have to be positive, or they both have to be negative. But if they add to give you a negative, that means that they both must be negative then, because that's the only way you'll get a positive product and a negative sum. So if you list off the factors of 40, 1 and 40, if they're both negative, will not add to give you negative 14. 2 and 20 will multiply to give you 40, but when they're both negative, they will not add to give you negative 14. 3 doesn't go into it. 4 and 10, if they're both negative, will multiply to give you positive 40 and will add to give you negative 14. So your numbers that you're looking for your factors would be negative 4 and negative 10. And it doesn't matter which order you put them in, but they have to be the same two numbers that have the product and sum that you're looking for. So that means your factors in factored form, that would mean you need x times x to give you the x squared, and then you would need the minus 4 and the minus 10 to give you the rest of it. So you'd have, this would be your answer. But if you want to check to see if you did it right, you could just multiply it out again, and you'd get x times x is x squared, minus 10x, minus 4x, plus 40. So that would give you x squared minus 14x plus 40. So you know you're correct. And the last one here, you need two numbers that multiply to give you a negative 36, and add to give you a positive 16. So the two numbers that multiply to give you negative 36 and add to give you positive 16, if you think about that, if they multiply to give you a negative, that means you must have one positive and one negative in order to have a negative product but a positive sum. So, and the bigger one would have to be positive if the sum is positive. So if you think about the factors of 36, 1 and 36, if one of those is negative, you're not going to have a sum of 16 when you add them. But 2 and 18 will work, because if the 2 is the negative, then they will multiply to give you negative 36, but add to give you 16. So negative 2, 18, negative 2, and 18. So your factors would be x minus 2 and x plus 18. And again, if you want, you can check. And you don't have to write it out. You can probably, after a while, you get so good at doing this, you can just check it in your head. X times x is x squared. X times 18 is 18x. Negative 2 times x is negative 2x. And negative 2 times 18 is minus 36. I kind of skipped a step there in my check. I was just doing it kind of in my head and writing it down at the same time. So that's x squared plus 16x minus 36, which is what we started with. So we know those are the correct factors. So here is just a little summary of what we just talked about. And if you're factoring a trinomial, you're looking for two numbers which multiply to give you the c with a constant and add to give you the b, or the term, the coefficient of the x term. When you're looking at tiles, it's also, you can factor using tiles if you can arrange them in terms of a rectangle. So in this case here, we would be trying to factor. If you look at what these tiles are representing, it would be a positive x squared, and there's 1, 2, 3 minus 3x tiles plus a 2. So when we go to factor that using tiles, they can be arranged in the form of a rectangle, and we just look at the outside dimensions. This dimension here would be a long, which would be representing x, and then 2 shorts, which are negative, so that'd be x minus 2. And this one here would be long, and then 1 short but negative, so that would be a positive x minus 1 along this side. So therefore our factors for x squared minus 3x plus 2 would equal x minus 1 times x minus 2. And if you check, x times x is x squared, minus 2x minus x will give you negative 3x, and positive 2. Negative 1 times the negative 2 will give you positive 2. So that will multiply to give you what we started with. All right, so this page here just basically gets you to do some extra practice with finding the methods of factoring. So in this one, you're not given the middle term, but you have to figure out a middle term so that this could be factored. So basically, if you kind of work backwards and say, well, I would have to find, if it's factorable, I would have to find 2 numbers that multiply to give me 10. And then whatever I put in there that multiply gives me 10, when I add them, it should give me whatever's in that box. So if you think about it, there's more than one answer for this, but one possible answer would be 2 and 5 gives you 10. So therefore 2 plus 5 would be 7, so 7 should go in that box. You could also say 1 and 10, and if you said 1 and 10 were your 2 numbers, then 11 would have to go in the box. In the next example, we have the middle term here would have to be 2 numbers that multiply to give you negative 9, and the 2 numbers would have to add to give you whatever's in the box. So if you think about that, just think of any 2 numbers that multiply to give you negative 9. Say, for example, negative 9 and positive 1. Then negative 9 plus 1 would be negative 8. So negative 8, so we'll change that to a negative and make that an 8. And that would be factorable then. And the last one here, you'd be looking for 2 numbers that multiply to give you 18. And the same 2 numbers that multiply to give you 18 should add to give you whatever you're going to put in that box. So if I pick 3 and 6 to multiply to give me 18, then 3 and 6 have a sum of 9. So that means 9 should go in my box there. In the next example, you're not given the last term. So if you look at the last term, again, you don't know what that last term is, but you do know that the 2 numbers you're looking for should multiply, if this was factorable, to give you what's in the box, but should add to give you the coefficient of the middle term is 1. So you would have to come up with 2 numbers that add to give you 1. So this would be, for example, 4 and negative 3 add to give you 1. So you put those same 2 numbers up in the top line there. You would have to have a product of negative 12. So that would mean you would need x squared plus x minus 12 would have to go in the box. The next one, you need 2 numbers that multiply to give you whatever's in the box, and they would have to add, though, to give you 5. So we'd have to start with what we know. We know that they have to add to give us 5, so I just pick any 2 numbers that add to give me 5, and then figure out what their product is. It would be 6, so that means 6 would have to go in that box in order for those to be factorable. And the last one, you're looking for 2 numbers that multiply to give you what's in the box, and they have to add to give you a negative 2. So if you pick 2 numbers that add to give you negative 2, for example, negative 5 and 3, then negative 5 and 3 have a product of negative 15. So in the box, you would want negative 15. All right. The next examples are practice examples for factoring. And we have the first one here. We are looking for 2 numbers which multiply to give you 6 and add to give you negative 5. So if you think about that, if they multiply to give you positive and add to give you a negative, that means they must both be negative. So that would have to be negative 2 and negative 3. Would multiply to give you a positive 6, but will add to give you a negative 5. So therefore your factors would be x, and you need minus 2, minus 3. And you can do a quick check if you want to see if they do, when you expand it, you do get back x squared minus 5x plus 6. And you do. You get x times x is x squared, minus 3x minus 2x will give you the minus 5x, and then plus 6. The next one, you're looking for two numbers that multiply to give you a negative 48, and add to give you a positive 8. So two numbers that multiply to give you negative 48 and add to give you positive 8. That would have to be, think of the factors of 48. And again, if they're multiplying to give you a negative, one has to be positive and one has to be negative. So if we think of the factors of 48, 1 and 48 will not work if one of them is negative. They won't have a sum of 8. 2 and 24 will not work if one of them is negative. You will not get a sum of 8. 3 and 16, if one of those is negative, you will not get a sum of 8 when you add them. 4 and 12, though, will work, because if the 4 is the negative and the 12 is the positive, you will get negative 48 when you multiply, and you will get positive 8 when you add. So therefore, you can go straight to your factors. You know that the first term in the factor has to be x for both of them, because x times x will give you the x squared, but then you need a minus 4 and a positive 12. And it doesn't matter if you wrote that as x plus 12 and x minus 4, or x minus 4 and x plus 12. You'll still get, whoops. Okay, so the next one, you're looking for two numbers which multiply to give you a negative 72 and add to give you a negative 1. And that would be negative 9 and 8. So you can go straight to your factors. First terms would have to be x, and then it'd be minus 9 and plus 8. The next expression, you're looking for two numbers that multiply to give you a negative 24 and add to give you a negative 2. And that would be 6 and 4, and you need the 6 to be the negative. They would multiply to give you negative 24, and they would add to give you negative 2. So your factors would be w minus 6 plus 4. All right, so the next one starts off with a 2, but if you look, 2 is a factor of all three of those. So one of the first rules of factoring is always factor out a GCF first, if it's possible. So always check for a GCF first when you're factoring. It's really important. It helps make your factoring work a lot simpler. So in this case here, there is only a GCF of 2, and what's left inside would be a p squared plus a 3p minus a 20. Now, with this one here, you'd be looking for two things that multiply to give you negative 20 and add to give you a 3. And you can check all the factors of 20. Well, one would have to be positive and one would have to be negative. But 1 and 20, if one of those is negative, will not have a sum of 3. 2 and 10, if one of those is negative, they will not have a sum of 3. 4 and 5 are the only other factors of 20. And if one of those is negative, you will not get a sum of 3. So basically, all the factors that multiply to give you negative 20 will not add to give you positive 3. So this is factored as much as possible. You can't go any further. So there is no, if there are no numbers that fit that expression, then those sum and product that you're looking for, then you're done. All right, the next one, there is a GCF of 3 first, so that would become b squared minus 6 divided by 3 is the 2, minus 2b, and then minus 15. And then you should check this a little further. You're looking for the trinomial inside. Are there two numbers that multiply to give you negative 15 and add to give you negative 2? And there are. They would be negative 5 and positive 3. So that means you can factor this a little tiny bit further. You would actually go down to the trinomial can be factored to b, and one would have minus 5 and the other one would have plus 3. Okay, so our last two examples there, we have this one here. Now a lot of people will leave it like it is. I tend to like to put them in order of descending power. So first thing I would do would be switch that around and write it like this. And then I would proceed to look for two numbers that multiply to give me negative 30. And again, after a while, you don't have to write down this step that I'm putting here now. If you can do it in your head without having to write that down, by all means do so. So two numbers that multiply to give you negative 30, so that means one of them has to be negative. And I can think of it right away. That would be 10 and negative 3 would multiply to give me negative 30 and add to give me 7. So then I can go straight to my factors here. And I can write m and m plus 10 and minus 3. And then the last factoring here, if we look at that, there's a GCF first that comes out. And even though there's not all three terms of that trinomial are negative, the first term the leading term is a negative. So when you're factoring, it's much easier to factor if you take that negative out, even if it's only in one of the terms. But if it's in the first term, you should take it out. So I'm going to take that negative out with my GCF, and that's going to leave me with h squared. And it's going to give you a plus 4h, because you've taken the negative out. And then, because the last term is positive, by dividing it by negative, that's going to make what's left inside a negative. So 60 divided by negative 5 is negative 12. And then you would be looking to see if that trinomial inside can be factored. So you'd be looking for two numbers that multiply to give you negative 12 and add to give you the positive 4. And that would be 6 and negative 2. Two numbers that multiply to give you negative 12 and add to give you 4. So that means that our trinomial would be h and h, and this would be plus 6 and minus 2. These are two factors. All right, so there's some questions there listed at the bottom there from page 166 to 167 that you can try to practice the topics that we've done in this section.